Basically, it is a feedback-based machine learning technique in which an agent learns to behave in an environment by performing the actions and seeing the results of actions. So here the agent learns automatically using feedbacks and there is no label data unlike supervised learning. And since there is no label data, the agent is bound to learn by its experience only. Basically, this algorithm is mainly used in game playing, robotics, etc. So where it learns by looking into the environment and interacting with in the environment, then it will learn itself. So using the reinforcement learning algorithm, the agent tries to improve the performance by getting the maximum positive rewards. And the agent learns with the process of hit and trial based on the experience and it learns to perform the tasks in a better way. I will show you one example how this is done using reinforcement learning algorithm. Let me first share you my screen. So hope you are able to see my screen now. Here I have talked about the agent. So suppose we have one agent, that is one robot we have. Here one kind of maze is there. So you might have known the maze, what is maze. So it basically some defined paths are there. So there some obstacles will be there. So uh, without uh, uh, by avoiding that obstacles, we have to reach our destination. So that maze we are considering. One robot is there, or and some obstacles are there. So here fire is there. Here also fire is there. Here fire is there. Then here fire is there. And here is our reward. So this agent robot is present within the maze environment, and his goal is to find a reward, which is we are considering a diamond here. So it is the reward it has to reach. Then the agent will interact with the environment by performing some actions, and those based upon those actions, the agent will change its states. From suppose it's moving from here, it will move somewhat here. So it is changing its states from here to here. because it has to avoid these obstacles, fire. And by looking into the environment, it will move. So it will move from one state to another state, and finally it will reach the reward, which will be its destination. And by doing these actions, it will learn and explore the environment. So these actions will lead to positive feedback or the reward which we are considering this. And if it gets the reward, then it is getting a positive point. And if it is not getting the positive reward, then it will get a negative point. Means every time the state will be changed. So basically here some terms I have used in this reinforcement learning algorithm. So one, I have already shown you that one agent is there. So these things will be involved mainly in reinforcement learning. So it is an entity that explores the environment and act upon it. Here in our case was a robot. Then I have told about the environment. So it will be the situation in which the agent is present and surrounded by. So here it was the maze in this case, and the actions will be taken by that agent because it is continuously moving from one place to another. So the action is done by the robot. Then comes the state. So it is the situation returned by the environment after each action taken by the agent. So from one state to another state, it was moving. So that I have already told you. So it continuously changing according to the environment and the action taken by the agent. Then the reward towards which the agent was moving. And I've already told you about the positive feedback and negative feedback. So positive feedback is then returned once the reward is reached. Then comes the policy. So it is the strategy that was applied by the agent for the next action based on the current state. So it was the main strategy. And then the value. So it is the value how the agent has reached the reward and returned the positive value after it reaches the reward. And then one key value. So it is mostly similar to the value, but it takes one additional parameter as a current action. So only it will have the current action. So it is updated there in the Q value. So that's the difference between Q value and the value. So the main key features of the reinforcement algorithm is the agent is not instructed by the environment and what the actions need to be taken. So it is not previously defined to the agent. It has to learned by itself according to the environment it is present. And then it is based on the hit and trial process also. First, the agent will see if the path is clear. If the path has some obstacle, then it has to divert to towards a free path. Like that, it will move. And then the when the agent takes the next action and changes the states according to the feedback of the previous action. Also, the agent may get a delayed reward according to the obstacle, whatever it comes into its path. Also, the environment is stochastic, and the agent has to explore to reach the maximum positive rewards. So, by these are the key features of the reinforcement algorithm. So, positive and negative reinforcement learning can be uh, uh, divided of the reinforcement learning algorithm. So in the positive reinforcement learning algorithm, positive reinforcement, so it means adding something to increase the tendency that expected behavior would occur again. And it impacts positively on the behavior of the agent and increases the strength of the behavior. So each time the state is changed, then whenever the reward is whenever the agent moves towards the reward, so the positive behavior of the agent is measured here. But this type of algorithm may lead to overload of states, which can reduce the consequences. So the states are continuously updated once the agent moves. So in positive reinforcement, this can be somewhat uh, drawback. And negative reinforcement. So it is opposite to the reinforcement, positive reinforcement, as it increases the tendency that the specific behavior will occur again by avoiding the negative condition. So it can be more effective than the positive reinforcement depending upon the situation and behavior, but it provides reinforcement only to meet the minimum behavior. Then comes the agent, how to represent the agent state. So the agent state can be represented using Markov state. So it contains all the required information from the history, like where the agent has moved from which one state to another state. Everything is every information is present. So it basically gives the information about the states, and it follows the Markov property, which says that the future is independent of the past and can only be defined with the present. So as the reinforcement learning algorithm is works on fully observable environments where the agent can move by observing the environment, and it will move from one state to the next state, and follows Markov property. I have not prepared any slides for this, just I am explaining the reinforcement learning. After that, we will see how we can apply it through Python. So basically, the classifier and regression algorithms are mainly used in real time conditions. If we are having some data set, so then we can apply those algorithms. So reinforcement is not much applicable. It is somewhat high level, and the complete process is known as the Markov decision process. So it is one of the reinforcement learning technique. Here, the agent constantly interacts with the environment and performs the actions. And at each action, the environment responds and generates a new state, which we can show diagrammatically. Here one agent will be there, which will interact with the environment. State is there and the reward is there. And the action taken by the agent in that particular environment. So this MDP, Markov decision process, describes the environment of reinforcement learning. This MDP has a tuple of 4 elements. So S is the set of finite states. Then A is the set of finite actions. Then the rewards received after transitioning from state S to state S dash due to action A. P is the probability of the action. This MDP, we can say it uses the Markov property, which states that if the agent is present in current state S1 and performs action A1 and move to the state S2, then the state transition from S1 to S2 only depends on the current state and future action, and states do not depend on past actions, rewards, or states. This MDP uses this Markov property, which states that so past any action or state is not considered in the Markov property. Only the current state transition and the action taken is considered. This we can say in the game of chess where the players only focus on the current state and they do not need to remember the past actions or the states. Then another technique we can say is Q learning in reinforcement learning. So it is an off policy reinforcement learning algorithm which is used for the temporal difference learning. And the temporal difference learning methods are the way of comparing temporally successive predictions. This we will see what it is. So flowchart we will see. So here we have the flowchart that explains the Q learning. So it learns the value function Q of S and A, states and action A, which means how good to take the action A at particular state S. So here the action is performed, and first we have to select the action to perform, then the selected action is performed, and after that the reward, how whichever the reward is there, it is reached, and then it will be updated in the Q table. So basically it works like updating every performs action and states taken by the agent. And then one more we will see, which is deep Q neural network, DQN. So from the name itself, it is, we can say it is Q learning using neural networks. So suppose we, for a big state space environment, so it will be challenging and complex tasks to define an updated Q table. So if we are having a very big state space, suppose many states are there. So each time updating that state into the Q table is very difficult. So in that case, we are using DQN algorithm. So instead of defining the Q table, neural network approximates the Q values for each action and state. So this is somewhat having the Q learning steps, but instead the neural network is used. And this Q learning is basically based on the Bellman equation. So here it will learn the policy which can inform the agent that what action should be taken for maximizing the reward under what circumstances. And it will try to find the best action to take a current state. So I will not very deep dive into the Bellman equation. So it is having some what mathematical formulation. Just I have explained you about the agent, how it is moving and how it is changing its state from one state to another while moving towards the reward. So it will basically calculate the states and it basically find out the Q values, which is the quality of an action taken by the agent in each state. Then comes the value iteration. So it refers to the best action for a given state by selecting the action that maximizes the optimal state value function for that state. And the optimal state value function is computed using an iterative process where we initializes the state value function v with random values and then iteratively improves the estimate until the reward is reached. So here in each iteration the value of q of states and action and the value function of the state values are updated, and it basically guarantees the best possible results by optimizing the state value function until it converges to an optimal solution. So it is also one another technique in reinforcement learning. Here also somewhat mathematical formulations are there. So basically we are updating the value function here. First starting from the state s equal to 0. Then we will move on to next state s1, then s2, then s3 until the reward is reached. And this value iteration is also following the Bellman equation. So it basically finds the optimal policy while uh, selecting the best action for a given state, and that action is selected to give the best optimal state value function for that state. So policy I have already told you earlier. So here it basically looks into the very much optimal policy while moving from one state to another. And means the best strategy applied by the agent is computed, or we can say the best strategy is considered here. So using this value iteration. And it is very much suitable for small to moderately sized MDPs, which is Markov decision process. And after this, we have the policy iteration. This will be more clear if we will see some examples to solve. In the later class, we will see how we will solve this with some examples. Then it will be very much clear to you. So here two phases are there in this algorithm. One is policy evaluation and another is policy improvement. So policy evaluation is used for computing the values for different states of the environment using the policy. Means the strategy that has been taken by the agent. And the policy evaluation and the policy improvement is the next step after the policy evaluation that monitors the state's values and tries to improve the policies to get higher values. So basically both are evaluated together. The policy improvement is evaluated after the policy evaluation. So initially the agent will assign a random policy, means a strategy that will result in the values of the state from one state to another, how it is moving. Then the policy improvement will try to improve the policy and will assign a new value to the state. And this will be continued back and forth between the two phases until the optimal value of the state is found. So here also will not very much deep dive into the mathematical uh, things. So just you learn this learning reinforcement learning techniques how they are working and how they are implemented. And this policy iteration is somewhat faster than the value iteration, and it also requires the solving the policy evaluation step exactly or approximately. So the difference we can say between value iteration and policy iteration. So here it requires fewer iterations. But computational effort is more for iteration. Here iterations are required more, but the but each iteration is simpler. And computational if the computational resources are limited, then this value iteration is used, and for the policy iteration the exact solutions are computationally feasible. So these two are the main difference between the value iteration and policy iteration. So we are using this best use in both the cases. So basically we have some states for the agent and the actions performed by the agent. Then we have to find out the most optimal state which will lead the agent to the reward. So these are some of the techniques used in reinforcement learning. It will be somewhat uh, related as many mathematical things are involved in this, and this we will see in our next classes, in our upcoming classes. So any doubt you have till now, can ask. Mainly in our workplaces also, we are mainly using the classification and the regression algorithms only. So this reinforcement learning is somewhat more advanced, you can say, and the many things are involved in this. So we will see in the next class how we can implement all the algorithms we have learned in the earlier class, including this. Any doubt you have? Else we can conclude the class here today. Okay, we will see in the next class. Today we are concluding the class here.